All right. Previous class, we have done this question. Based on this question, we have these two questions. This one and this one. Okay. Both will be done with the second law. F net is equal to ma. F net is the force in the direction of motion minus opposite force that we have to use and do this question. Question number 13 and question number 27. Okay. Then tension we have seen, and based on that, let's do this question. What is the question? Let's see. The suspended body of 75 Newton is this shown, and is the T greater than or equal to or less than 75 Newton when the body is moving upward with the constant speed at increasing speed. The body is moving upward, we make the FPD. This much is the FPD of the free body of the block. तो उसके लिए equation लिखेंगे F net is equal to ma. Since it is going up, the upward force is the tension first minus opposite force mg is equal to m into a, or T will be mg plus ma. So mg is 75 plus ma. Now in first case, a is 0, constant speed a is 0, the whole term becoming 0, tension is 75. So at constant speed, you have to apply the same force, whatever is the weight. If you apply the 75 Newton, you can make it upward with the constant speed. Now second case, acceleration, increasing speed means acceleration positive upward. So this whole term will be plus. So tension required will be more than 75. ये तो 75 है plus something extra. So depending upon how fast you are increasing the speed, more and more tension will be required than 75. All right. Moving on to the next one. Equilibrium already we did. Equilibrium में क्या होता है? Net force is 0. है ना? So this was the question given to you. This system is in equilibrium. What we do, an angle is asked. What we do, we'll take this block first. उसका FBD बना लिया tension. Tension is T here, and downward force is mg. Since it is in equilibrium, T will be equal to mg. Net upward force will be equal to net downward force. So T is equal to mg. So this is for block M. Now we'll take the central block. This tension will go like this. It's two component. Upward component is along with the theta, that is T cos theta, and this component away from the angle will be T sin theta. Similarly, this tension, it's one component T cos theta will be here, other component T sin theta will be here. These two component T sin theta will balance horizontally, and these two component T cos theta will balance its weight m root 2g. इसकी weight को balance करेंगे. तो ये दोनों force add कर लिए. 2t cos theta is equal to weight of this block root 2 mg. Now t की value put कर दो इधर से. mg. तो ये mg cancel हो जाएगा. Cos theta will be root 2 by 2. That will be nothing but 1 by root 2. Theta will be 45. So each angle will be 45. Total angle will be 90. If they ask you what is the total angle, you have to add both. So the answer is 45 degree of this question homework problem. What we did is equilibrium of this first, वहां से हमें T मिल गया. फिर equilibrium of this point or this block, we can say this block पे ये point इस point के साथ block है. If this point is in equilibrium, this block will be in equilibrium. Tension के component resolve कर लिए. Upward cos theta, horizontal sin theta will cancel, and 2t cos theta will balance this weight m root 2g. So after solving, theta is 45 degrees. Moving on to the next one. This question was done. This was given to you in homework. What we did in this horizontal component of this force will move the system forward. इसका horizontal component निकाल लिया था हमने. F cos theta, that is 20 into 1 by 2, that is 10 Newton. So horizontal component of force is 10. So acceleration of system will be horizontal force divided by total mass. That's 5. 10 by 5 will give you 2 and 2 SI unit. Now टेंशन निकालने के लिए इसका FBD बना लेंगे यहाँ पर. इसमें कितने फोर्स लग रहे हैं हॉरिजॉन्टल डायरेक्शन में? ओनली T, नो अदर फोर्स इन हॉरिजॉन्टल डायरेक्शन. तो F net is equal to M1A, that is T is equal to M1A. M1 is 2 kg. इसको 1 ले लो M1, इसको M2. So 2 into 2, 4 Newton. It will be 4. Tension will be 4 Newton. Clear? First we find out the acceleration, then we can find out the tension. Now if blocks are interchanged, 3 kg this side, 2 kg this side, then acceleration will remain unchanged, total mass remain unchanged, but tension will change. Now 3 kg block, यहाँ पे 3 आ जाएगा. T will be 3 into 2, that will be 6. Now tension will be more because it has to pull the bigger block. 3 kg block खींचने के लिए ज़्यादा tension होगा. If we interchange the block, acceleration will remain same, but tension will go up. Now, we have this question in NCERT book. 2 blocks are connected with the light inextensible string goes over the frictionless pulley. For solving such question, we have to learn theory first. So we are doing theory. It is just for numerical sake, not other thing. Numerical solve करने के लिए देख रहे हैं only. And this system is also called Atwood machine. When 2 blocks are there connected with the inextensible string passing over the pulley, which is fixed at rigid support. तो इसके लिए acceleration and tension का derivation कर रहे हैं so that we can save the time. तो pulley is massless. Ideal condition है. This pulley is massless and smooth pulley, so that this string will just slide over the pulley, will not turn the pulley because it is frictionless. And the string is ideal, therefore tension same throughout, and it is inextensible. Therefore, both blocks will have same acceleration. One will have downward, other will have upward. Magnitude of acceleration remains same. So first we'll make the equation of motion for this. I mean, Newton's second law will apply on this block. M1 is bigger than M2. This will go down. M1G minus opposite force tension. Tension will come due to the blocks hanging. So F net will be force in the direction of motion. This is going down. That force will be taken first minus opposite force tension is equal to M1A. This is equation 1. For this block, M2 block, tension is upward. Again, tension like this, and M2G like this. Since it is going up, tension has to be bigger. F net में T will be coming first, and opposing force will be M2G, will be coming later, which will be equal to M2A. ठीक है, तो this is the equation 2. If we add 1 and 2, 1 plus 2 कर दें, तो ये terms TT will get cancelled. So we will be left with this. इसमें से A common ले लो, यहाँ से G common ले लो, इसमें और इसमें. And A के लिए solve करेंगे तो it will be M1 minus M2G upon M1 plus M2. Magnitude, one is going down, other is going up. So यहाँ पे sign convention नहीं है. ये magnitude है इतना. One is going up and another is going down. That's all. If you want to find out the tension, put the value of A in equation 2. यहाँ पे put कर दो. T के लिए solve करो. इसको इधर भेज दो यहाँ पर. So solve it. Take LCM also. Solve it. You will get this. T is equal to M1 M2G upon M1 plus M2. Okay. So these are the equations. We can use it directly. If you remember, fine. Otherwise, make the equation and solve it. अभी हमें एक्सेलेरेशन का डायरेक्ट शॉर्टकट देखें क्या? यस, शॉर्टकट लिखने के लिए एक्सेलेरेशन का नेट फोर्स अपॉन टोटल मास. तो net force में M1G is greater, that will tend to go down, but M2G will oppose it because of gravitational pull on it also. That will oppose, so net force will be M1G minus M2G divided by total mass M1 plus M2. So it is coming same. Can you see? A shortcut method. Okay. Now tension in the pulley, which is holding the tension in the string, which is holding the pulley M2 dash. ये पुली पे रोप के टेंशन, स्ट्रिंग के टेंशन डाउनवर्ड आ रहे हैं. ऑलवेज टुवर्ड द सेंटर, टेंशन की डायरेक्शन टुवर्ड द सेंटर ऑफ द स्ट्रिंग. ऐसे ब्लॉक है, दोनों टेंशन दोनों ऑब्जेक्ट को पुल करेंगे. पुली को इधर पुल करेगा, ब्लॉक को ऊपर, सेंटर की तरफ टेंशन की डायरेक्शन आती है. तो ये टेंशन नीचे है, तो टी डैश विल बी इक्वल टू 2t. ये पुली तो मासलेस है, पुली इज मासलेस एंड इट इज फिक्स आल्सो. इट इज नॉट एक्सीलरेटिंग, इक्विलिब्रियम में है. तो अब टोटल अपवर्ड फोर्स इज इक्वल टू टोटल डाउनवर्ड फोर्स. ये दोनों 2t हो जाएंगे. All right. Now we can solve this question. One block is 8 kg, the other is 12 kg. Bigger को M1 लेंगे, irrespective of left and right. जिधर भी है वो नीचे जाएगा. Bigger block will pull the other block. तो M1 we have taken bigger there. तो 12 को M1 लेंगे. Putting the value formula में, तो 2 meter per second square आएगा. Tension will be 2 and M1 M2G upon M1 plus M2. टेंशन की वैल्यू इसमें पुट करके टेंशन भी निकाल सकते हैं. इफ यू डोंट रिमेंबर द फार्मूला, मेक द टू इक्वेशन एज वी डिड इट एंड सॉल्व इट फॉर ए एंड टी. ठीक है. नाउ इसका सेकंड पार्ट मैं होमवर्क में दे रहा हूँ. फाइंड डिस्टेंस कवर्ड बाय ईच ब्लॉक इन 5 सेकंड इफ बोथ आर रिलीज फ्रॉम द रेस्ट. वन विल गो अप, अदर विल गो डाउन, डिस्टेंस कवर्ड विल बी इक्वल. So that you have to solve in the homework. We'll see tomorrow. All right. Now this question we can skip. इसमें देखिए horizontal, one of the block is on the horizontal surface. We have to make equation. इस block की तो same रहेगी. This block, this is the smooth surface. Irrespective of any mass m1, will pull the m2 irrespective of any value of m2. Friction नहीं है तो ये इसको आगे जाना ही है. ये ब्लॉक उसको नीचे खींच लेगा ना, आगे खींच लेगा, तो ये तो नीचे जाएगा. इसकी इक्वेशन विल रिमेन सेम. m1g minus t is equal to m1 ने. एक्सेलरेशन इज डाउनवर्ड, डाउनवर्ड फोर्स फर्स्ट लिखेंगे सिमिलर टू द प्रीवियस केस. एंड इसकी इक्वेशन लिखने के लिए देखो एक्सेलरेशन इधर है, तो हॉरिजॉन्टल डायरेक्शन के फोर्सेस लेंगे. तो हॉरिजॉन्टल डायरेक्शन में केवल एक ही फोर्स है t. m2g नीचे है और t नॉर्मल रिएक्शन ऊपर है. तो ये फोर्सेस 90 डिग्री वाले फोर्सेस इनको डिस्टर्ब नहीं करेंगे, है ना. हॉरिजॉन्टल फोर्सेस केवल लिए जाते हैं, अपोजिट फोर्स तो कुछ भी नहीं है इसमें. तो ओनली t इज इक्वल टू m2 है. ऑलराइट. This solid example you can see 5.12. And this is the homework, you can do it. Here tension will be equal to centripetal force. That will be m omega square r, which is also equal to mv square by r. These formulas you can use it for this question. That's all from my side.